Okay, so this video is going to cover writing the equation of a line. So basically, to write the equation of any line, you have to have two scenarios. You got to cover two scenarios. So one of the scenarios can be that you are given a slope and you have some sort of point to then build an equation off of. The other scenario is that you're given at least 2 points. However, scenario 2 still requires you to get back to scenario 1. So overall, to write the equation of any line, you need to figure out slope, and you need to have data in the form of a point, somehow, some way, of 1 point. I could give you 300 points. You only need to use one of them. I could give you 40 points. You only need to use one of them. I could give you 2 points. You only need to use one of them. Point being, you will have to 100% figure out slope somehow, some way from the data that is given to you, and then you will need to use a point within that data that you used to calculate the slope to then write the equation of a line. So, below, I have some formulas along the way. So y equals mx plus b. This is called the slope-intercept formula. It is just a format that a line comes in. It is also probably the common way that you will see a line written, and it is the way that you graph from. It is the one that is the most useful when it deals with all sorts of things when it comes to graphing a line. The second one here is just an equation that allows you to rewrite back into y equals mx plus b. So it gives you a starting point to finish at y equals mx plus b, and that's all it is. The last one is just a way for you to calculate slope if you need an actual formula, because you are not good with mental arithmetic, so you need to have something to plug into, so therefore you can actually calculate the numbers that you're looking at. If you are a person who is not very good or does not have strong mental arithmetic skills or number sense, then I am a person that will always suggest to you to use the formula, because it allows you to revert back to the calculator for now to help you out with the fact that you are struggling with your mental math skills at the current moment. So, if you have good mental math skills, though, I will show you how this formula is kind of a little over the top. Like, you don't need to use it if you don't want to. But if you like that formula, please, by all means, do so. I will try to show you as many possible ways of doing the problem. Please note that this video is going to have a plethora of methods, so do not mix up the methods, because if you start mixing one method with another, it can get confusing, but I am showing you a bunch of different methods so that hopefully one of them clicks with you, and that you are able to then go ahead and use that method to accomplish the task. So let's look at some examples. Example number 1. Example number 1 will simply cover if I'm given all of the information from scenario 1. What if I'm only given the slope and 1 point? So the first way that I will do this will be with y equals mx plus b. The second way that I will do this is what we call the point slope formula, which will then be used to then go ahead and convert it back to y equals mx plus b. So you can either choose to use y equals mx plus b exclusively, or you can use the point slope form to then turn this into y equals mx plus b. Either way, my final answer will be in the form of y equals mx plus b. So here we go. The only things that I am not given in this problem, okay, are, if I look at the y equals mx plus b, is that I'm given 1, it tells you whose rate of change. So write the equation of a line whose rate of change is 2/3. A rate of change is also the variable for m, so I can come down here and say m equals 2/3. It then tells me that this line also passes through the point 12, 11. If I have a point, points come in the form of coordinate pairs x comma y. So right now I know that x equals 12 and I know that y equals 11. So this is kind of important because as you can see right now, the original equation y equals mx plus b has 4 variables in it, yet I only have 3, which I actually need to only have 3 because I am essentially giving you a problem that is requiring you to solve for b, and once you have solved for b, you will then have your equation for your line. So what you need to do is the property called substitution. Substitution is if you have a value that is associated with a variable, you can simply plug it into the equation that has that variable in it, and then you can calculate for the one that is left that is not there. So for this formula, y equals mx plus b, I'm going to go ahead and use substitution. So y becomes 11 equals, my m is 2/3, so 2/3. X is 12, so 2/3 times 12, and then I am left with plus b. So at this point, I am left with an equation that has the variable b, which is important because if I want to solve for something, then I am going to need to have a variable left in the problem. So what I can now do is I can go ahead and do a two-step equation and get my variable b, and I will then be done. So we do 2/3 times 12 is the first step. So 2/3 of 12 is going to be 8. Plus b equals 11. The second step of this problem will be to subtract 8, and what I get is b equals 3. Now, the reason I like y equals mx plus b, and I am a fan of using this one myself, is simply because every time this is literally a two-step problem. You do a multiplication, and then you do an addition or a subtraction. You will then have your b. So now that I have b, I can write my final equation. Now, what we need to note is that x and y that I'm boxing up here are coordinate pairs. These are points. In the final equation, I will need the y and the x to be in the problem as x and y, because if I put a 12 and 11 in, I then no longer have an equation. So, I need to represent lines having a bunch of points that continually change as I move along the line. So we leave the y and the x in the problem because there are two things that don't change in the line, and that would be one, the rate of change, and the second part would be the part where it started from. Those are the only two things that never change on a line. However, the coordinates continually change. So I'm left with y equals 2/3 x plus 3 as an equation. Now, going over to the other side, let's say I wanted to use this y minus y1 equals m times x minus x1. So, very similar, same type of thing. However, the difference between this one is that if I put multiple x's in a problem, I use subscript to denote which variables I actually will be substituting for. So in a formula that has multiple x's or multiple y's, if it does not have a subscript, then now I have a problem in which I will not be substituting for those. So this particular formula, if it doesn't have the subscript, is saying to you, never substitute for me, because if you do, you will then lose the integrity of the problem, and they don't want you to do that. So what we need to do here is I have x, I have m, and I have a y. And as I've just done before, if you note before in the problem, I had m was 2/3, I had my x was equivalent to 12, and I had my y was equivalent to 11. This particular problem does not have a b, so we don't need to worry about the b. This problem will, after we rearrange it, will come up with the final equation just by simply simplifying it. So here we go. We go ahead and we plug in. So y minus. Now you need to plug in the y value that you have. The y value that I have is 11, so it's y minus 11 equals the slope that I have, which is 2/3 times x minus the x coordinate that I have, and the x coordinate that I have is 12. If this coordinate were negative, please note that the minus sign would change to a positive sign. However, I have two positive coordinates, so the negative signs stay as is. So from here, now it's just a matter of simplifying and rearranging it so that it says y equals. So the first thing that I might do is do the distributive property. So 2/3 times x, and then 2/3 times negative 12. So I get y minus 11 equals 2/3 x minus 8. The last step that I have to make sure of is that now I'm going to have to go ahead and I'm going to have to get rid of the negative 11. It can't be y minus 11. It needs to simply say y equals. So I use a property of equality, which is plus 11. And I go over here, write plus 11. And I am now left with y equals 2/3 x plus 3. And what you have here is you have an equation at the end that matches our final answer from before. So, two different ways to get to the same answer. Does not matter which you use. I am just a fan of getting correct answers, and the bottom answer is the correct answer there. On to the next one. So the next one now is this scenario 2. So scenario 2 now doesn't give me slope, which then is a problem because the only way I can write the equation of the line is if I do know the slope. So there are two ways of gathering and getting information to get slope. The first way of doing so is that I'm going to show this now using the formula first. After we use the formula, we will then use the formula, and then we will use, in green again, I will use the point slope formula. So if I'm going to use formulas, I'm going to stay with formulas. So here we go. So the first formula here for m is found by taking y2 minus y1 and x2 minus x1. So if I'm going to go ahead and use this formula, what you need to do is you need to go up here and decide which one of these is 0.2, which one is 0.1, and then you should start labeling those things. So if I call the first one as I see it, 0.1, I'm going to label that as x1, that is y1. This is x2, this is y2. And from here, what I do, again, if I'm using formulas, is I use the act of substitution. So you must substitute your values in. So here we go. So I say m equals, so y2 is 5, minus y1, which is 3, divided by x2, which I'm saying is 9, subtract off x1, which I'm saying is 4. So m is going to be 5 minus 3, which is 2, and divided by 9 minus 4, which is 5. So what I have is a slope of 2/5. Now, once I have this slope of 2/5, I now am in the scenario of I've got slope. I now must go choose one point. I don't care which one point you use. However, I will be using the formula of y minus y1 equals m times x minus x1. And what I would suggest for you here is, because you've already labeled your points 0.1 and 0.2, that you go ahead and just continue to use your points as 0.1, 0.2. So what this means is, after I have the slope, I go ahead and I do substitution yet once again into another formula. And I'm going to use the point slope formula. So here we go. So y minus y1 is 3 equals m, which is now 2/5, times x minus x1, which is 4. At this point, I will then go ahead and solve from here. So what I'm going to do is now I do the distributive property. So 2/5 goes in through, so I'm left with y minus 3 equals 2/5 x minus, so 2/5 times 4 is 8/5. Now, this one's not looking out very pretty, but that's okay. I don't want you to think that everything has to be nice and pretty, because that is not the truth in real life. So we now go like such, and I need to solve for y. So we do plus 3 plus 3. So now, negative 8/5 plus 3 is going to be 7/5. If you don't know the answer to that, and you can't do that mentally, or you can't do that by hand, then you will have to resort to the calculator in this case. But the answer will be 7/5. So negative 8/5 plus 3 is positive 7/5. So you are left with your final answer of y equals 2/5 x plus 7/5. So the second method. So if you are a formula person, I know it seems crowded over here, but I hope you were able to follow along with the method I had. Now, the other way is this table method. The table method is you make an xy table. So x, y. And what you are going to do is you are going to plug your points in. So you're plugging your points in. So 4, 3, then 9, 5. So from here, what I'm going to go ahead and do, okay, so what I'm going to do from here, I'm going to move this over in a second. So from here, what I do is that I go ahead, and what I end up doing here is that I go ahead and I'm going to find the rate of change. So from 3 to 5, that is an addition of plus 2. From 4 to 9, that is an addition of plus 5. So what I have here is that this is, sorry, I moved to here, so this is plus 5. So what I now have is I've got plus 2 and plus 5. And when I write my equation, what you need to know is that my equation still is the change of the y's divided by the change of the x's. So to go from 3 to 5, it was a change of 2. To go from 4 to 9, it was a change of plus 5. So my m is simply 2 over 5. So I get the same thing. I'm just going to be using mental math there. From here, I do the same thing as before, except I'm going to use y equals mx plus b this time. So I say y equals mx plus b, and this is now again where I begin to use substitution. So the substitution I'm going to use is I'm going to pick a y value matched with its x. So in this particular case, I have multiples to choose from. You only need to choose one pair. But if I pick, say, 3, I must then use 4. So I can't use y as 5 and then use a different one. You must choose them as pairs. So I'm going to use the coordinate pair 4, 3. So here we go. I will say substitution, my y is 3 equals 2/5 times x, which is 4 plus b. So at this point, I'm simply solving for the b that I don't know. So I do 2/5 times 8, so I get 3 equals 2/5 times 4, which gives me 8/5 plus b. I then subtract 8/5, subtract 8/5, and I will get b is equivalent to 7/5. So once I have that as my final that right there, that b, my final answer again will be this y equals 2/5 x plus 7/5, and then I'm done. So remember, when you do the final equation, you still have to put it in there. It does not matter which one you do. If you notice on the left, it's a little bit less space of arithmetic than compared to the right-hand side, and that is literally the selling point on the left compared to the right, but it does not matter which one you choose. So again, on one. So this particular one, I'm going to continue on with doing the same type of deal. So in blue, I'm going to do the table, and then I will go into y equals mx plus b. On this side, I will do the formula, which is m equals y2 minus y1 divided by x2 minus x1, and from that, we'll go into the point slope formula. The right-hand side, I will stay with formulas, and the left-hand side, I will stay with the table method, then into the other formula. So here we go, the table method. So if I use my table, x, y, I'm going to plug my points in, which is -3, 5, and 9, 13. So again, I'm just going to do some mental arithmetic. From 5 to 13 is an addition of 8. From -3 to 9 is an addition of 12. So again, I've got my change in y, and I've got my change in x here. So I have +8 and +12. So my m is always going to be the right side of change divided by the left side of change. If you understand that I mean that this is the change in y's is 8, and the +12 is the change in x's. So it is always the y's over the x's. So you will get that it is 8 over 12. Now, from here, you should always reduce, because m is a unit rate of change, which means it is a simplified fraction. So in this case, I get 2/3. So m is now 2/3. Once I have m as 2/3, I then go to my y equals mx plus b. And from here, again, it is simple substitution. You use any point that you want. So in this case, I will use the point 913 with my m of 2/3. So substitution, 913, 13 is in the y column, so I will replace it with y. So 13 equals 2/3 times 9 plus b. From here, I do the multiplication, I then subtract or add it over, and then I will have my b for my final answer. 2/3 of 9 is 6 plus b. So 13, subtract 6, I get b equals 7. So my final answer is y equals 2/3 x plus 7. So again, going to the other side. So that again was with the table going to y equals mx plus b. The other side will be using the formula. So formula side, you need to choose, in this case, which one you are calling point 2, which you are calling point 1. So I'm going to call this x1, I'm going to call this y1, I'm going to call this x2, and this will be y2. I have labeled them, and now I go on. So m equals, so y2 is 13. I'm going to do minus y1, which is 5, divided by x2, which is 9, and then I'm going to subtract the x1, which is negative 3. So yes, be careful. One of the common mistakes here that people will make is that they won't put the negative there because they'll see the minus already. Don't make that mistake. So we go on. So 13 minus 5 is 8. And the 9 minus negative 3, again, this is for people who don't have those mental skills, mental math skills as much as they would like to have them, but this is a way to help you do it, so that way you can type in the calculator 9 minus negative 3 if you had to, and you would get the number 12. Now, from here, we are still not done, because again, we will still need to reduce this, so this will then become 2/3. So once we have m is 2/3, we then can now go into the y minus y1 equals m times x minus x1 formula, which is the point slope formula. And from here, I'm just going to plug in my values that I've already have labeled with x1, y1, and my m, so I'm going to use substitution again. So here we go. Y minus y1, which is 5, equals m, which is 2/3. Times x minus, again, my value, which was negative 3. So what I'm going to now do very quickly is I'm going to clean this up, because I notice I have a negative with a negative, and we should not have that. We should know that that becomes plus. So I get y minus 5 equals 2/3 times x plus 3. So now from here, I do the distributive property, so I get y minus 5 equals 2/3 x plus 2/3 times 3, which is 2. My last step from here would be to add 5 to both sides, and when I do that, I will finish with y equals 2/3 x plus 7. So I still get to the same answer. Again, like I said to you, if you notice the right is just a little bit more of a formula arithmetic. But if you like that method, please, by all means, use that method if it is helpful for you.